Hello, it's me again, and I'm in my car waiting for my son to get out of a golf lesson. So, you got that quiz back today, right? And a lot of you really struggled on how to pick the right K value, how to calculate it. So I wanted to show you guys this really cool thing. Miss Schneider totally taught it to me, and I think you guys are gonna love it. So if you take a look up here for diprotic and polyprotic acids, so I just mapped out the first acid, and then Ka1 to lose the first H, right? Charge is one step more negative. And then Ka2 to lose the next H, so now it's a -2 charge. And then Ka3 to lose the last H, right? Okay, so, and there's the respective values. Okay, now for this particular quiz, you guys had two salts. The one, this guy right here, there's no way this one could be acidic because after the NAs are gone, there's no acidic hydrogen. Okay, so this one had to be basic. And then this guy down here, well, it at least, once you get rid of the NAs, has an H to donate, so this one is amphoteric and will be acidic. So let's start with this one. And if you have the other quiz, it's in a different order, but same idea. So there's my ion, 2- charge, and it's going to act like an acid, so it lost an H+, and this is the conjugate base. So what Ka value do we use? Okay, so here's how this little trick works. So we go back up here and we just match it up. So this is HC6H5O7 2-, right? And it's losing an H, acting like an acid to make this conjugate base. So guess what? You're going to use Ka3 because we're going from here to here. And we're going in the forward direction, so we're using Ka because it is acting like an acid. So we would use, indeed, Ka3. Okay, so there it is. And then you can solve like normal. You can solve for the x value and take the negative log of it, and the pH is around 3. Okay? If you had the other form, it's a little bit different. Okay, so that's how that works. Now, if you come up to this one, well, this was C6H5O7 3-. So again, if you match that up on this little graph, or this little graphic organizer, it's right here. And according to the reaction, it's acting like a conjugate base. So it's going to gain that H, makes this guy, right? And you generated OH-. So because of that OH-, you know you need a Kb. Okay, so you come up here. You're like, okay, so I'm going from here, and then I'm gaining an H, and I'm making this guy. So I'm going backwards. So I don't need Ka, I need Kb, so that's when you actually have to calculate it. But I'm still going to use Ka3 to make that calculation happen. So I come down here, and here's Kb, 1.0 times 10 to the negative 14th over Ka3, okay? And that gives me my Kb value, and then again, you can solve for the OH, and then you got yourself a basic pH, around 9.51, a little different if you had the other form. Okay, so you guys, it's that easy for diprotic and polyprotic acids. If you just sort of map it out like you see here, as long as you can find what you're starting with and you see where you're ending, then you know exactly what you have to use. If you're going in the forward direction, you're using the Ka values. If you're going in the backward direction, then it's acting as a base, and you got to use the appropriate Kb that you would calculate. Man, I hope that helps you guys. Thank you so much. It's a rainy, dreary day here at the golf lessons, so thanks, and we'll see you guys on Monday.